Welcome to the presentation of the poster 17-epi-stanozolol N-glucuronides as novel stanozolol marker substances in routine anti-doping analysis. My name is Georg Stadler and we conducted this work at the Institute of Applied Synthetic Chemistry, TU Wien, Vienna, Austria, in cooperation with Cybersdorf Laboratories. What is stanozolol? Stanozolol is the molecule on the left side and is a synthetic, anabolic, androgenic steroid which enhances muscle growth. It is the most often detected anabolic steroid in professional sports, and therefore the analysis and identification of its metabolites is essential for anti-doping analysis. Usually, urine samples of athletes are analyzed, and two analytical methods are available for the detection of doping abuse. First, gas chromatography, where you have to cleave the conjugation of the urinary phase II metabolites enzymatically or chemically to obtain the corresponding phase I metabolites. After extraction of them, they are globally silylated to lower the boiling point of the substances for GC analysis. This is by now the standard method for the analysis of steroids, but it is highly laborious and time-consuming because of the two necessary reaction steps. Another method, which is less time-consuming during the upstream process and therefore preferred for anti-doping analysis, is liquid chromatography. Here you can extract the urinary phase II metabolites by solid phase or liquid-liquid extraction and detect the metabolites afterwards. For some steroids, it is also possible to analyze the phase I metabolites with liquid chromatography after extraction. 17-epi-stanozolol is a known phase I metabolite of stanozolol and believed to be a long-term metabolite for this doping substance. 17-epi-stanozolol has 3 different positions where glucuronic acid can be attached in the human body, but only the glucuronides of 1'N and 2'N are confirmed up until now. To investigate the natural occurrence of these molecules and to prove the proposed structures, they have to be synthesized and used as reference substances. We focused on the synthesis of N-glucuronides and started with an epimerization of stanozolol by sulfation with sulfur trioxide pyridine complex, which is hydrolyzed under basic conditions afterwards. The resulting 17-epi-stanozolol was then treated with mercury salts and sugar bromide to obtain the protected glucuronides in a ratio of about 2:1, 2'N to 1'N. The formed glucuronides were deprotected under basic conditions and quenched with H+ resin to provide the needed metabolites in high purities. Afterwards, we analyzed the reference substances with liquid chromatography and compared them with stanozolol-positive urine samples. First, you can see the stanozolol-positive urine sample, second, a stanozolol-negative urine sample, the so-called blank, and last, the blank spiked with the synthetic reference materials. According to the obtained data, the believed metabolites are formed naturally in the human body. Generally, 1'N is formed in higher amounts compared to 2'N. In the lower chart, the detection windows of stanozolol and 17-epi-stanozolol N-glucuronides are shown. 2'N glucuronides are detectable only during the first days after administration, whereas 1'N glucuronides are detectable for several days. Especially the 1'N glucuronide of 17-epi-stanozolol is detectable for up to 28 days, and 1'N stanozolol glucuronide for up to 13 days. In conclusion, we are now able to synthesize N-glucuronides of 17-epi-stanozolol in high purities and have a method available to detect stanozolol abuse up to 28 days. The Partnership for Clean Competition is acknowledged for financial support. Thank you.